Okay, so in this last tutorial, we did this kind of complex flow over the surface of this mesh to make this line network, which looks pretty good. Um, in the next tutorial, we're going to do something that is a fair bit more ambitious. I don't actually know if it's going to work. Now, a common thing that I've always wanted to do with these generative models is you have some complex chunk of geometry like this, and you want to create a distribution over the surface of the mesh that represents some kind of paneling system, like shingles or something like that. Now, the thing that makes it complex is when you're flowing things over the surface of the mesh, the logic that determines where things want to flow is quite different to logic that wants to keep lines spaced apart. So you tend to get a whole lot of lines which are bunched together really close, or a whole lot of lines that are a long way away from one another, which is completely different to the more uniform distribution that you want when you want to shingle something. So we're going to see if we can modify this script and prompt it so that the distribution of shingles is actually much, much closer together. So what we'll try is we'll just try prompting it. So we're going to say we want to use these streamlines as the center lines for shingle geometry that should be evenly distributed across the surface. The streamlines are important because we need shingles to gradually shift in direction in response to the curvature. The mesh, however, we need to ensure that the shingles always overlap by a fixed amount. Let's assume a mesh box of given dimensions for a shingle, then generate streamlines that are valid center points for rows or for, like, let's say, runs of shingles. Ask questions if you need things clarified before writing the code. That's always a good trick. So if you're not sure whether or not you are being explicit enough with what you're asking for, you can always just tell the model to ask you questions to clarify anything which is maybe ambiguous in your prompts. This is especially useful if you yourself are not actually certain about your own design intent. You can always just ask the model. So let's see what we've got here. It's asking us a whole lot of stuff. So we've got shingle dimensions and overlap. When you say mesh box of given dimensions, I'm thinking of a rectangular shingle with length, width, and thickness. Is that right? Yep, that's right. For the overlap, is the overlap along the streamline direction like roof shingles, or lateral overlap between adjacent streamlines, or both? Yeah, so we want both. That's important. What's the exposed portion? Okay, to get even coverage, streamlines need to be spaced apart by roughly the shingle width. Yep, show auto compute streamline spacing from the shingle width. Yep. Poisson disc style seed placement so streamlines are evenly spaced across the surface rather than randomly distributed. Yes. So yes, let's say, okay, yes, shingles need to overlap along streamlines and adjacent with adjacent streamlines. Yes, we should do Poisson uniform distribution of initial points. Each shingle be an actual mesh box. Yep. Let's choose a mesh box. Let's allow us to pick a mesh box, and we can use that for shingle dimensions. Slight offset from the surface, flat planar quads. Use Okay, it wants to know the bounding box of the mesh. Sure, bounding box. Paste that in. All right. This is kind of exciting because I haven't tried this ask questions thing to begin with, and this is already pretty useful. So I'm going to make my little mesh box for the shingle. We'll make it fairly small. And I'm going to move this down to, oops, just put the shingle near it so it's a bit easier to see what's going on. Shingle size is not that. Those dimensions. Mesh, we are flowing along. The shingle is, how big is the shingle? We don't need a gravity vector input. Okay, see how it goes. So this, if it can do this task, this is definitely high level of difficulty. There's a lot of constraints now. We've got kind of generative constraints of this iterative process of drawing the streamlines, which before could be done in parallel. Like each streamline didn't really care about what the other streamlines were doing, so you could just make all of them all at once. Whereas now we actually care about all of the existing geometry that's on this surface. Every time we add a shingle, it's affecting the valid placements of the next set of shingles, and that's what makes this pretty hard to code traditionally. We've also got this set up so that we have flexibility in terms of being able to run this over any mesh and with any shingle geometry or panel geometry, which is really, really useful as a design tool. We're not locked in to one particular way of doing this, say contouring, or it only works on certain kinds of geometry and not on others. With the flexibility is critical if we're going to actually use this as some kind of design tool. I'm expecting this is going to be a pretty big script. There's just a lot of different aspects. It's already 500 lines long to do the flow. I wouldn't be surprised if this one's, over 1,000 lines long. But we will see. In fact, just because it is so long, I'm going to pause the video and we'll come back to it once it's finished. Yeah, it wasn't actually that long. It's only 700 lines. I'm sure we're going to have to iterate on this some more. So let's click run. I'm going to make sure that I save this run chart just by clicking in the name, because there's always a chance that we're going to crash this when you're running scripts. Even though we've told Opus how big this geometry is, it hopefully gets the defaults right. You never know. So target mesh to flow shingles along, that's going to be this one. Select the shingle mesh, that's going to be that one. Overlap percentage, 30%. Let's make it 10% for now. Curvature direction, stagger alternate rows, that sounds good. Interesting. So this time it hasn't let us choose the number of seeds. It's going and doing that itself. based off the need to create certain overlap, I presume, between all of these shingles. So already that's actually a pretty useful um, addition that it's made to this script, because determining how many, oh wow, it's already done it. Okay, that's pretty cool. We've got way too many shingles, or at least our shingles are way too big. I suspect that the 10% overlap might have been the other way around, as in it's like massively overlapping it. So let's try running that again. Delete that. And I might make this shingle just a slightly different shape. So I want to know. Actually, let's just extrude it. I'm curious to see the direction of the shingles, and then I think I made that shingle just way too big for this geometry. So let's try running it with this smaller one. Mesh, as the shingle mesh, overlap percentage, we'll just leave it as 30 for now. Okay, so this time it's placing 4,800 shingles. That's way more shingles, so I'm going to pause the video. I cancelled that one. I didn't want to wait for it. So we can already see this running here. It's going to make our shingles brown, which is actually kind of annoying. So the overlap percentage is way too much, I think. I think we need to tell it that there's too many points which are overlapping. What I'm going to try doing is just sending it a screenshot so that it can see what we're talking about. Okay. Overlap along the curves is good, but between the curves, we aren't computing this properly. We need a better way of distributing the curves. I think I'm going to ask for this to be a two-step process. Let's do this as a two-step process. First, we should create the curves and show us a preview. Then we should generate the mesh geometry. All right, I'll pause the video. We'll come back to it. Okay, I'll come back to it now, actually, because what Opus has decided to do is really interesting. So it's saying that the way that it has to do this now is to grow streamlines incrementally. So it creates a streamline, then offsets that and creates the next one. And that's exactly right. That is the challenging but required process that we need to follow here. And so it's saying, yep, this is a major rewrite. And so I think that is what's going to lead to our script being quite a lot longer. So excited to see what it does here. I'll pause it, we'll come back. Okay, so it's gone and generated it with this incremental offset approach, which is definitely better, but it looks like we still have a lot of these kind of streamline curves which are too close together. So what I'm going to do is I'm going to screenshot this, prompt it to Opus, and have it figure out a way to distribute these better, because we definitely don't want to put shingles on this just because we can see already that this isn't evenly enough distributed. So we'll pause this, we'll come back to it. All right, again, really, really interesting how Opus comes back to this. So it's identifying from the screenshot straight away that the initial points that it set out are valid, but then while it's generating the streamline, it's not doing checks. And so that's how you end up with this bunching. Again, this is having written this kind of code myself, this is exactly the types of issues that you come up against. And so Opus is identifying them, and we'll see if it can do it. Okay, we're back. Let's try this out. So it said that we need to do coverage-aware tracing. It's changed some of the spacing, and so let's see how we go. I'm going to guess that this is over 1,000 lines now. Oh, just under, but that's about what I would expect. Okay, so we're going to run step 1 streamlines, pick the target mesh, select the shingle mesh, overlap percentage. Let's make that smaller, 20. Curvature direction. Okay, nice. That is incredible, and that is exactly what I would expect this to look like. So we're just going to bump up the number of streamlines now. So we're going to run that again. Okay, step 1 streamlines, target mesh, shingle mesh, overlap percentage. I think maybe we can do 30, you know. And let's say we can do up to 600 because it seems like it's pretty fast to generate. Okay, nice. That looks extremely good. So let's do the next step then. Haven't tried the next step yet. Step 2, shingles. Overlap percentage along streamlines, 30, yep. Sounds good. Stagger alternate rows, yep. Placed all of our shingles, nice. That looks pretty good. Pretty good for the amount of time we've done on it, that's for sure. Awesome. So I guess hopefully this shows you how straightforward it is to get to a point where you have really quite complex design constraints. You know, we're getting into sort of fabrication constraints and things like that now. And this is all completely doable by the model within a fairly short space of time and for fairly low cost. Like all of this is with Opus. This last script cost 900 credits, which is about 50 cents. So in terms of the amount of time that it would normally take to write this kind of code with this kind of logic, it's a lot of time. It's now down to kind of a few minutes. So very, very excited to see what everybody can come up with I'm just going to grab those meshes. I think I might change the color on them. It's gone and labeled it. See what people can come up with these kind of techniques. You know, there's more to do here. Like the main thing I think that would make this look good is to make sure that all the shingles are aligned in the same way. So we've got shingles that are all aligned in slightly different directions here. So we'd want to flip all of these curves to make them consistently aligned. I might actually do that. I'll pause the video, so that'll just be the last thing that we show. Okay, we've added that. Let's try running it. Streamline step, target mesh, shingle mesh, overlap percentage. I think we want that smaller. We'll make that bigger. And it's going to go generate. Okay, nice. Let's only put it on this bottom bit this time. That'll do though. So let's run the second step. Shingle step. That looks heaps better. Okay, let's join that and let's make them default color. Beautiful. So now we've got all of the shingles more consistently flowing in one direction. We've got pretty consistent overlap. Still not perfect. I think we could tweak that quite a bit more. But that is looking pretty good. So we'll chuck this script up on the or the run chart workflow in the description. You can try this out yourself and have fun.